In the criminal justice system, mathematical-based offenses are considered especially heinous. Employing to normal, the dedicated detectives who investigate these vicious felonies are members of an elite squad known as the Special Calculus Unit. These are their stories.
Okay, girls, it looks like we have a big case on our hands. The chemical plant Chemicals R Us had an intentional leak.
Oh wow, is everyone okay?
Unfortunately, no. 2 workers didn't see the spill occur, and it leaked into their break room and burned off their feet.
Oh my gosh, what can we do to help this guy?
Well, we definitely need our department specialty. The leak came from one of the tanks inside the plant. The tank holds 10 gallons of water each and 4 pounds of toxic chemical each. Pure water was added to the tank at 2 gallons per minute, and the mixture was drawn from the tank at the same rate. There were only certain people in the room with the tank to create this leak. We need a special calculus unit to figure out at what time was there only 0.1 pounds of toxic chemical per gallon left in the tank. This way, we can catch our monster and bring him to justice.
Don't worry, the Special Calculus Unit is on the case. Wow, this is a really tough problem. I haven't had a problem like this since my Math 146 course in college.
With Dr. Day?
You had him too?
Helped me pass that course.
Best teacher I ever had.
However, I always seemed to struggle when it came to using differential equations.
Wow, seriously? You're in the Special Calculus Unit. That's like second semester calculus.
Whatever, okay? It looks like the first thing we need to do is create a differential equation. Let's make it dx over dt.
Right. This will describe the rate of change in the amount x in pounds at time t.
Exactly. So we will take dx over dt equals the rate in minus the rate out. This comes out to be equal dx over dt equals 0, what we had in the beginning of the tank, minus x over 10 times 2 gallons, which becomes dx over dt equal to x over 5 pounds per minute. Okay, so what it looks like what we're saying here is that dx over dt equaling negative x over 5 is actually separable. So if you take dx over x, you get to be equal to negative 1/5 dt. And if you take the integral, you would take the integral of 1 over x dx, and that would be equal to the integral of negative 1/5 dt. So when we come from that, you get the natural log of the absolute value x is equal to negative 1/5 t plus c. C being our constant, of course. So if we're simplifying, we get x equals e to the negative 1/5 t plus c. And to simplify that even further, we can take x equal to k e to the negative 1/5 t. Wow, nicely done. But let's find out a value for k. Okay, if x equals 4 pounds, x of 0 equals 4 pounds, then k has to equal 4 when we plug it in, making our equation equal to x of t equals 4 e to the negative 1/5 t. Beautiful. Okay, so it looks like all that is left to find is how many minutes after the tank had originally started leaking is there 0.1 pounds of chemical per gallon. Okay, let's see t so that x equals 1 pound. So 1 equals 4 e to the negative 1/5 t. Using simple algebra, we can find that the natural log of 1/4 equals negative 1/5 t, which is approximately equal to 6.93
0.15 minutes.
Wow, the TI-89 sure knows how to
Love
calculate.
that thing, huh?
So perfect. Let's go check the timesheets and figure out who is working on the tank at 6.315 minutes after the tank had originally started leaking.
Let's do it.
OMG, his name is Newton Leibniz. No way, let me see. Well, it looks like he'll be back to work in a half hour. Want to do some calculus probably? Is that even a question? Of course.
2, 1, go.
You meet tomorrow, 5 p.m.
Alright, let's get this on there. I think we're ready.
You have the right to remain silent. Anything you say can and will be used against you in court of L'Hopital's law. You have the right to a calculator. If you cannot afford a calculator, one will be provided for you. Do you understand the rights I have just read to you? Yes, I do.
Wait, you have a last name Leibniz? What kind of last name is that?
Well, congratulations, SCU. You did a job well done, and for that, I will give you the most prized Medal of Honor.
Medal of Differential Equations. Where